Hello guys, welcome to my YouTube channel. In this video we discuss about inference theory of statement calculus. Here in inference theory of statement calculus we have to know about the rules of inference. In rules of inference we have we have to know about first is premise. What is a premise? The definition of premise is it is a proportion of statement on the basis of which we would be able to draw a conclusion. That means there are set of premises. By using that set of premises we try to draw a conclusion. That is called premise. That is, if here is given P1 premise and P2 premise and P3 premise, in between we are placing and by using and symbol in this three preposition we came to know an conclusion, last conclusion, conclusion or draw a conclusion, then it is called a premise. Here have a note, if premise then conclusion, that means like this only. Here P1 is premise and P2 is premise. In between this premise we are placing and we draw an conclusion, that is P3 or Q. It is called as premise. If premise then conclusion, that is P implies Q, that is P or premise Pn equals to Q. All set of premises then conclusion, that is Q. This is an premise. Here and I will explain you with an example, then you can understand clearly. Okay, don't worry. Here second one we have to know about argument. What is an argument? It is a sequence of steps that end with the argument. Okay, here argument means it is a sequence of statement that ends with an conclusion. Sorry, here we have written the argument. Now here is conclusion. Here means every statement, that is every statement or premise, that is P1, P2 and P3, how to be end with an conclusion, that is Q. We have to end with an conclusion only. Okay, this is a argument. Then what is valid argument? Here argument and valid argument there is some difference. Here valid argument means it is said to be valid if and only if it is not possible to make all premises true and conclusion false. That means here if given P1 premise, P2 premise and P3 all are true, then the conclusion is true, then it is called valid argument. If premise is true and conclusion true, that it is called valid argument. If the premises P1, P2, P3 are true and conclusion false, then it is called as invalid argument. The given definition is said only that only if it is said to be valid if and only if it is not possible to make all premises true and conclusion false, that we have to make the premises true and conclusion also true, then it is called valid argument. If it is possible to make the premises true and conclusion false, then it is called invalid argument. Here let us consider an example. Here given premise is P1. Premise P1 is I love cat and then I love dog. And premise P2 given I love cat, conclusion is I love dog. Let us take here, let us assume here P equals to I love cat and Q equals to I love dog. Okay, by assuming this, by comparing to this given premises, we write the here answer. Here we assume that P equals to I love cat, Q equals to I love dog. Here in the premise one given that I love cat, that is P na I love cat equals to what? P. So P then means what we can assume? P implies Q only na. If means this, if then means it will be replaced as this symbol. So I love cat, then implies I love dog. Dog means what? I love dog means Q. This is Q. Here P minus 2 means what? I love cat, that is P. Here conclusion means therefore. The conclusion is represented as therefore. I love dog means that is Q. This is the given answer to this question. So we check here it is a valid argument or not. So how to check it is valid argument or not means here using truth table. Take P, Q. P is true, false. Q is true, false. Here given what first is P implies Q. Okay. P implies Q means in P implication Q, if P is true and Q is false, then the whole statement is false. In other cases it will be true. We know that. We have learned in the previous video also. Here we know that here in the rules of inferences, in between premises we have to place and in conclusion we have to write implication. That is, this can be write as P implication Q and P implication Q. Okay, we have to in between premises we have to place and symbol, and in between premises and conclusion we have to place implication symbol. Here in the note we have learned if premise then conclusion, like this. So here P implies Q and P. Okay, it is a P implies Q, and here values of P implies Q, here P values. In between we have to place and if two are true, then only the whole statement is true. We have learned that. So here true is there, so it is true. False true means false. True false means false, and true false means false only. It is for the P implies Q and P. Now we have to do P implies Q and P implies Q, because it is the last statement. So here this is a value and this is a key value. In between we have to place implication. In implications, if P is true and Q is false, then the whole statement is false. We know that. Here true means true. Here false. Here true means true. Here false means true only. Here false true means true, and here false means true. So here in the P implies Q and P implication Q truth table, we have all values in true only. So it is a tautology. If P implies Q is a tautology, then it is called as valid argument. So here P implies Q and P implication Q is a valid argument. Can say as valid argument, because in this P implies Q and P implication Q having in this truth table all true, so it is a valid argument. You can conclude it is a valid argument or not by using truth table or having some rules of inferences, that is some rules are there, formulas are there. By using that formulas also you can conclude that it is a valid argument or not. So by using this way, using truth table, it is a valid argument, because in this truth table all values are in true only. That is called tautology. So it is P implication Q and P implies Q is a valid argument. Now coming to second method, that is here are some rules, formulas or rules. Here the first rule is modus ponens rule, that is P implication Q and P gives rise to Q only. This is first formula. And second is modus ponens rule, that is P implication Q and negation Q implies negation P. Third one is hypothetical syllogism, that is P implies Q and Q implies P implication P implies R. This is the third rule. The fourth rule is disjunctive syllogism, that is P or Q and negation P gives rise to Q. Fifth one is addition loop. P implies P or Q and sixth one is P or Q and negation P or R implies to Q or R. These are the 6 rules are there, but without using truth table means we have to use these rules to find the given premises and conclusion is valid argument, rules of inferences is valid argument or not. Let us consider an example. By using this formula we solve this question. So here given the question is Randy works hard, comma, if Randy works hard then he is a dull boy, comma, if Randy is dull boy then he will not get the job. Let us start the problem. Here let us assume, here we have to assume that P equals to Randy works hard, that is negation P equals to means it is negation P is the opposite value to P na. Here Randy works hard, so here negation P means Randy does not works hard, not work hard. Now Q equals to he is a dull boy, he is a dull boy, that is negation Q is the opposite value to is, he is not a dull boy. Okay, here R equals to he will get job, so negation R equals to what, he will not get the job, he will not get the job. These are the assumptions of our this problem. So comparing this assumption to this, comparing to this problem, we write the rules of premises and conclusion. So here first of all given that, that is premise 1, given that Randy works hard, that is P up to comma means this is the first premise. Here Randy works hard, Randy works hard means it is a P because P equals to Randy works hard. Now the second premise is if Randy works hard, if Randy works hard, that is P, then he is a dull boy, that is implies he is a dull boy means what premise, that is Q premise. If Randy works hard, that is P implies then he is a dull boy, that is Q. Here the third premise, if Randy is dull boy, that is Q, Randy is dull boy then he will not get the job, that is he will not get the job means what, negation R na, that is if Randy dull boy, that is Q, implies then means implies he is not get the job, that is negation R, negation R. Here I forgot to write the conclusion also in the given question. Here conclusion given Randy will not get the job, get the job is the conclusion. So these three are the premises. Here conclusion means therefore Randy will not get the job, that is he will not get the job means what, negation R na. So here conclusion is negation R. So these are the premises and these are the conclusion. If it is a valid argument or not, how to conclude that? By using these rules we have to conclude it is a valid argument or not. Here see, here you can see here P is there, here P implies Q is there. By seeing this, here we can use the modus tendency rule, modus ponens rule, that is modus ponens rule is what, you can see there P implication Q and P gives what, R, Q only. So here P is there, P implication Q is there. We know that here in the premises we replaces and then we here replace, here you can see P and P implication Q and Q implies negation R, then implication R we can, this is a, we write premises like this way. Here in this place we can substitute what, here you can see in the model P implies Q and P implication what we have Q. So in this place according to modus ponens rule, that is P and P implication Q, we replaces what, Q. So in this place we replaces Q. So here in the place of P and P implies Q we replace Q, and here Q implication negation R implies negation R. So we have to equate this to this, or we have to equate to this. Here you can see here Q is there and Q implication negation R is there. So here let us take it is as P and it is Q. Just take it is as P and it is and Q. Assume it is P and it is Q, and take it is also P. By modus Pennon rule, we know that P implies Q and P, we get implication Q answer. So here it is P implication Q and it is P. By using this in this place, comparing this two, we get what? Q na. So here Q value is what? Here negation R. By comparing this and this, we get negation R, implies negation R, that is this equals to this. So it is a valid argument. By these all premises, we get the answer is negation Q, that is equal to conclusion. So it is a valid argument. Like this way we can conclude that it is a valid argument using these rules. Again here I am explaining. First of all, we write the given question like this premises, and then by using rules, applying rules in this, we conclude that the given premises are equal to the conclusion, that is negation R equals to negation R. So it is a valid argument. Hope you people love the video, guys, and like, share, comment and subscribe, and click the bell icon to be notified every update from my small studies YouTube channel. Thank you, guys. Hello guys, welcome to my YouTube channel. Hope you people like the video. Keep supporting me by subscribing the YouTube channel, and like, share, comment and click the bell icon to be notified every update from my small studies YouTube channel. Thank you, guys.